Good day. The topic we are treating today is proportion. We have two types of proportion. We have the direct proportion and the indirect proportion. But in this particular lesson, we talk about the direct proportion by Monserrat. So the objective of this lesson is to solve problem involving direct proportion, so that by the end of this lesson, you know how to solve problem involving direct proportion, you know how to convert from one unit to the other, and so on. So the topics you must have been well acquainted with before you can watch this video. The topics are addition, subtraction, multiplication and division of numbers, and conversion of units, that is how to convert from one unit to another, like from meter to centimeter, from kilogram to gram, from miles to kilometers, and so on and so forth. So now we move to the main thing, which is the direct proportion. What is direct proportion? If you have two quantities in which if one increases and the other also increases, then those two quantities are in direct proportion. For example, the quantity of a particular thing you bought from a supermarket, the higher the quantity, the higher the price. If you buy one biscuit, you can buy it for 5 naira. That's 5. When you increase the biscuit to 2, it becomes 10 naira. So you can see that the higher the number of biscuits you bought, the higher the price. So that means that quantity of biscuits and price of biscuit are in direct proportion. So that is what direct proportion is about. Two quantities are in direct proportion if one quantity increase at the same rate as the other. They increase at the same rate. So you can see that the biscuit is increasing by 1 and the price is increasing by 5. The increment is constant. It's not changing. It's constant. So that means they are in direct proportion. So for example here, if one packet of biscuits costs 100 naira, then how much will 2 packets cost? A single packet costs 100 naira. So we assume that we don't know what 2 packets cost. So we assume that 2 packets equals P, that's representing it with a variable. Now, if we should find the value of P, that means we have find the amount 2 packets of biscuits cost. So what are we going to do? We cross multiply. And I already taught you about how to cross multiply. Here, whatever we have at the left hand side of equal to sign here, we multiply it with what we have at the right hand side of the equal to sign here. We write down the result equals to what we have here, which is at the left hand side of the equals to sign in the second statement. We multiply it with what we have at the right hand side of the equal to sign of the first statement. This is it. We have 2 multiplied by 100. I will know after we get this, the unit will be naira. The unit here is naira, so the unit here will also be naira. So 2 multiplied by 100 naira is 200 naira. So one packet of biscuits costs 100 naira. Therefore, 2 packets of biscuits will cost was 300 naira. So we can 200 naira. Sorry. So we can also do the same for 3 packets. 3 packets will be, we use the same method. We have 300 naira. We can see that as the number of packets is increasing, the price is also increasing. Therefore, the number of packets is in direct proportion to the price of the packet of biscuit. So we can see that they are both in direct proportion. So 3 packets will cost 300 naira and then 4 packets will cost 400 naira. So we can generalize this. 1 packet costs 100 naira, 2 packets cost 200 naira, 3 packets cost 300 naira, and 4 packets cost 400 naira. So from the expression above, the cost is in direct proportion to the number of packets. So if 1 packet is 100 naira, as when we want to have X packet, that is, maybe X can be any number, and we say that, when we want to get the value for 2 packets here, we represent the price with P the other time. So now we want to get the value for X packet. The value for x packet, we represent it with y. So you know what we are looking for here is y. Y, you know, when you cross multiply, 1 multiplied by y, x multiplied by 100, x, and we know that the value here will be in naira after we get the answer. So this is an equation. So we can see that this equation connects x and y. If we have the value for x here, we can get the value for y, and if we have the value for y here, we can get the value for x. So the equation above connects y and s. It gives all possible values of y giving the value of x. So we can write it in general to be what? Y equals kx. You can know if we should relate this with the previous equation, which is the first equation, y equals 100s. We know that k will be equals to 100, and we call that k the constant of proportionality. So therefore 1 is a direct proportion, and it is written in this symbol. Y direct proportion is a symbol for direct proportion. Y is directly proportional to what? X. So k will be constant all through. You can see that here, assuming y equals, you know, if we have y equals 100x, for one packet, when x is 1, y will be 100, like we have for one packet 100, for two packets we have 200, for three packets when x is 3 we have 300. You can see that for every value of x we have a value for y. So that's why I said this k, which is 100 here, is always constant. It will not change. For every question you have, your k will not change. So now, and this is the symbol. If you have maybe distance is directly proportional to time, we have d, and you use this symbol, then you write time. So now let's move to examples to explain all what we have been saying. So the first example says a particular car travels 5 kilometers on every 2 liters. If he puts 2 liters of petrol in his car, is going to travel for 50 kilometers. So we have to write the relationship between distance d and the liters L. You know, here we are dealing about the distance the car can travel and the liters of petrol it's using. You should write it as an equation, and then we'll complete this table. That is, for 1 liter, how much distance is it going to move? For 2 liters, for 3 liters, up to 8 liters. So we are now told that assuming he traveled for 88 kilometers, how much petrol will he need to do that? And we should find out, if he should travel for 130 kilometers, how much petrol will he need? So we are going to do that. The second question also talk about Yewande, that is trying to improve her fitness. So she runs steadily at the rate of 4 meters each second. So per second, 1 second she runs for 4 meters. How many meters will she run in 2 seconds? We are going to find out that in this table. So we are asked to complete the table. In 1 second she runs 4 meters. How many meters will she run in 2 seconds, 3 seconds, up to 10 seconds? So we have to find the ratio that justify that distance run is proportional to the time taken. What you are going to do if you want to justify is they must have the same ratio all through. This first time and distance must be equal to the second time and distance up to the 10th time, 10 seconds, and the distance corresponding to that particular second. So after that, you have to write the relationship between the time t and the distance d as an equation. So how long we should run 100 meters? We have to look for the number of seconds she will use to run 100 meters, assuming she continues to run at the same rate. So that is the second question. It's a very simple question. So we also told that in the market, 450 grams of mushroom costs this. What is the cost of 1 kilogram? You know, the question is in gram, but we have to give the answer in kilogram. That is when conversion of units comes in. So now let's move to the solution of these questions. The first question says, let's check what the first question says. The first question says a car travels 50 kilometers on every 2 liters of petrol. So from the question, the distance is 50 kilometers and it is directly proportional to the liters used. And I told you that the symbol will be what? D alpha L. D is directly proportional, that is the distance is directly proportional to the liter. After this, so D is directly proportional to L. So when you want to remove this sign this proportionality sign, it becomes D equals KL. Remember we said K is the constant of proportionality. So the first thing you write is that your distance is directly proportional to liters, which implies that D equals KL. So now here we are told that the distance is 50 kilometer, D is 50 equals to, we don't know the value for K, but the liters used for 50 kilometer is 2. So we have 50 equals to K multiplied by 2. But we want to find the value of K, that is the value of our constant of proportionality. So what are we going to do? We divide through by the coefficient of K, which is 2. So if we divide both sides by 2, here we are left with K, and 50 divided by 2 is 25. So our constant of proportionality is 25. So we'll bring it back to the equation. The relationship between the distance, which is the first question, distance traveled, and the liters used will be what? D equals, we have D equals KL, and the value for K is 25. So we have D equals 25L. So this is the relationship between the distance and liters. So now, no matter the value of liters, we'll always get the distance it covered using that particular liters of petrol. Assuming it's 1 liter, it covers 25 kilometer. Assuming L is 2, it covers 50 kilometer, which is what we have in the question. For L is 3, it covers what? The car covers 75 kilometer, and so on. So that answers the first question. This is the relationship between the distance and liters. So now we are asked to complete a table of liters of petrol starting from 1 to 8. So what we are going to do is, now since you know the relationship between the distance and liters, you write D equals 25L. So now we start inputting the value of liters one after the other. So for 1 liter, we have D equals to what? 25 multiplied by 1, which is equals to 25 kilometer. They have filled the space for 2 liters already. So we'll go for 3 liters. We have D equals to what? 25 multiplied by 3, which is 75 kilometer. For 4 liters, we have, our L will be 4 then. It is going to be 25 multiplied by 4, 100. For 5 liters, we multiply 25 by 5 to give 125. They've done the one for 6 liters. So we move to 7 liters, we have 25 multiplied by 7, 175. And for 8 liters, we have 25 multiplied by 8, which is 200 kilometer. So using 1 liter, the car can travel for 25 kilometer. We can see that as the liters of petrol is increasing, the kilometer covered by the distance covered by the car is also increasing. So we can see here clearly that the distance and the liter are in direct proportion. So now we'll take this result back to the table, fill in the table again. So this is number of liters 1 to 8, then we'll fill in the distance corresponding to those numbers of liter. So for a liter of petrol, the car can travel for 25 kilometers. For 2 liters of petrol, as we have in the question, the car can travel for 50 kilometers. For 3 liters of petrol, the car can travel for 75 kilometers, up to 8 liters of petrol, which will make the car travel for 200 kilometers. So that is that on that. So we are asked to find the number of liters the car will need to travel for 1, it's 8 kilometers, and 2, 130 kilometers. The moment you find the relationship between distance and liter, that is what you will be using. So since D equals to 25 here, then for 88 kilometers, we know that this 88 kilometers is distance. We have to obtain the liters of petrol the car will use to travel for 88 kilometers. So we substitute the distance to be 88 kilometers equals to 25L. So we are looking for the value of L. So here we have 25L, but we are looking for the value of L. So what are we going to do? We divide both sides by the coefficient of L, which is 25. So if we divide this side by 25, we are left with liter, that is the liter of petrol the car will use, and then we divide 88 by 25. Using your calculator, we have 3.52. So the car is going to use 3.52 liters of petrol to travel for 88 kilometers. So that is what we have here. Therefore 3.5 liters of petrol will be used or needed for a distance of 88 kilometers. So we'll do the same thing for 130 kilometers. So for 130 kilometer, we have what? 130 equals to 25L. You know, we have D equals 25L. So our D is 130, but we don't know the L. Divide both sides by 25, we have L equals 5.2. So 5.2 liters of petrol will be needed to travel for a distance of 130 kilometers. And that solves the first question. It's as simple as that. So the second question says a particular girl named Yewande wants to have a body fitness by doing jogging. So she runs 4 meters in a second. She runs 4 meters. So this is it. 1 second equals to 4 meters. She runs 4 meters in 1 second. So she runs 4 meters in 1 second. So for 2 seconds, I think we have a table there to complete. We have to find the number of meters she runs for 2 seconds. So since we have 1 second to be equals to 4 minutes, we have 2 seconds. We don't know the number of meters she runs for 2 seconds. So we represent that with x, and we know how to cross multiply to get the value for x. And you know that after you get the value for x, the unit in front of x will be meter. So x will be what? 1 multiplied by x will give x. 2 multiplied by 4 will be equals to 8 meter. So she runs 8 meter in 2 seconds. You can see that as the number of seconds increases, the number of meters she runs also increases. So we deduce something. Therefore Yewande runs at the rate of 8 meter in 2 seconds. So from here we can see that the number of seconds you run equals to what? 4 multiplied by that number. Here we have 2 seconds. 2 seconds is equals to what? 4 multiplied by 2. 1 second is equals to 4 multiplied by 1. So we deduce that x for x seconds equals to what? 4 multiplied by x meter. I think you get that. For 1 second, the same thing as saying 4 multiplied by 1. For 2 seconds, it's 4 multiplied by 2. So for x seconds, it's going to be what? 4 multiplied by x. So that is what we'll keep on using. But that 4 multiplied by x, we have a unit meter. Here we are looking for the number of meter she will run in different seconds. So for 3 seconds, using this, our xa will be 3. 3 seconds will be what? 4 multiplied by 3, which will be 12 meter. For 4 seconds, we have 4 multiplied by 4, that will be 16 meter. So in 4 seconds, she can run a distance of 16 meter. So for 5 seconds, we have 5 seconds equals to 4 multiplied by 5, which is 20 meter. So we do the same. We do for 6 seconds too. 4 multiplied by 6. They've already done for 7 seconds, but assuming we did for 7 seconds, we have 4 multiplied by 7, which will give 28 meter, which is the same thing as what we are given in the table. For 8 seconds, we have 8 seconds equals 4 multiplied by 8, which is 32 meter. For 9 seconds, we have 9 seconds, which is equals to 4 multiplied by 9, which is 36 meter. And lastly, for 10 seconds, we have 10 seconds equals 4 multiplied by 10 meter, which is 40 meter. So this is the table. For 1 second, she runs a distance of 4 meter. In 2 seconds, she runs a distance of 8 meter. 3 seconds, she runs a distance of 12 meter. You can see as this is increasing by 1, this is also increasing by 4. So that is how it is. So we have to find the ratio of time and distance and use it to deduce that they are in direct proportion. Fourthly, this table already show us that the time and distance are in direct proportion, but we also use this. So the ratio distance will be what? The first one is 1:4, which is same thing as writing 1/4. The second one is 2/8, 2:8, that is in 2 seconds you can run a distance of 8 meters. 3/12, 4/16, 4/16, 5, that is in 5 seconds she runs a distance of 20 meters. In 6 seconds she runs a distance of 24 meter, and so we do that till 10 seconds, which will be a distance of 40 meters. So if we should take this to its lowest time, we still have 1/4. This to its lowest time, we have 1/4. If we should simplify this to its lowest time, we have 1/4. This to its lowest time, we have 1/4. Also, if we should simplify this to its lowest time, we have 1/4. This two, we have 1/4. This 1/4. Simplifying this to its lowest time, we have 1/4, and also this 1/4. We can see that everything, when all the corresponding distances and time are simplified to their lowest time, we have 1/4. Therefore, the ratio is constant all through, and that also shows us that the distance is directly proportional to the time. So that is the answer to the second question. Now, the third question says that we should show the relationship between the distance and time in an equation. So that is when we say, since we've confirmed that the distance is directly proportional to the time, we have d is directly proportional to time, and you know what this will change to? It's going to be what? D equals kt. You can see where k is the constant of proportionality. So since d equals 4 meters, you use what is in the question. You know, it said Yewande can run a second, can run 4 meters in a second. So d equals 4 meters and t equals 1 second. So d is 4 equals to k multiplied by 1. You know, t is 1, and you know k multiplied by 1 will give k. So therefore k equals 4. So substitute the value for k here back. So the relationship between the time t and the distance d is what? D equals the value for k, 4t. So that is the relationship between d and t. That is what is connecting d and t together, since they are directly proportional. So since d equals, so the first question says that we should look for the number of time Yewande will use to run a distance of 100 meters. So the first thing you say is, since you know the relationship between the distance and time to be equals to d equals 40, so what is the distance we have to look for? The time she is going to run it. We have to look for the time she is going to use to cover a distance of 100 meters. So the distance is 100 meters, but we don't know the time. So from the question, the distance is 100 and the time is unknown. So what we will substitute this value into the relationship d equals 40. So d is 100 equals 4 multiplied by t, which is unknown. So to get the value of t, we divide both sides by what? By 4. So dividing this side by 4, we are left with t, and 100 divided by 4 will be equals to 25 seconds. Therefore, it will take Yewande 25 seconds to run a distance of 100 meters. I hope that is clear. So that is as simple as that. So the third question says, in a particular market, 450 grams of mushroom is sold for 697 naira 50 kobo. We are asked to obtain the value. We are asked to obtain the value. We are asked to obtain the value 1 kilogram of mushroom cost. We can see that the question is in gram, but we have to give the answer in kilogram. That is when conversion of units comes in. So 450 grams of mushroom is sold for 697 naira 50 kobo. So the first thing we do is look for, we cannot just convert 450 grams to 1 kilogram. We'll first look for how much they sell 1 gram of mushroom. And you know that it would be very easy for us to convert from 1 gram to 1 kilogram. So that is a direct conversion. So if 450 gram of mushroom costs 697 naira 50 kobo, so 1 gram we don't know the cost for 1 gram. So that is why I represent it with x. So what will you do? You cross multiply. Cross multiplying means you multiply what is on the left hand side of the equal to sign of the first statement with what is on the right hand side of the equal to sign in the second statement. So that is why we have 450 multiplied by x, we have 450x, and we multiply what is at the left hand side of the second statement with what is at the right hand side of the first statement. So we have 1 multiplied by 697 naira 50 kobo. So we have 697 naira 54 kobo. And we know that this x is under the column of naira sign. So whenever we get the value of x, the unit will be naira. So 450x equals 697.50, but we are looking for the value of x alone, not 450x. So we divide this side and this side by the coefficient of x, which is 450. So x will be what? 697.50 over 450. If you use your calculator for that, you get 1.55. And I told you that the unit will be what? Naira. Since it is under the column of naira, x is under the column of naira, you can see this is gram, so this is going to be naira. So a gram of mushroom is sold for 1.55, that is 1 naira 55 kobo. So we already know the amount they sell 1 gram of mushroom. Now we convert, you know, we are asked to find the amount they sell 1 kilogram of mushroom. So since we know how much they sell 1 gram of mushroom, we can convert that 1 gram to 1 kilogram easily. So now we convert gram to kilogram. We all know that 1000 gram equals to 1 kg. So instead of writing 1 kg, you can write 1000 gram. So since 1 gram equals 1.1 naira 55 kobo, 1000 gram, which is also 1 kg, will be, we don't know, will be x. This is something you should know. 1000 gram equals to 1 kilogram. So 1 gram, the cost for 1 gram of mushroom is 1 naira 55 kobo. So 1000 gram will be equals to x. And you know what we do here? We cross multiply. 1 multiplied by x is x, and 1.55 times 1000, if you use your calculator for this, it's 1550. You know, it is under the naira column, so it's going to be in naira. So you know 1000 gram equals to 1550, and you know 1000 gram here is same thing as 1 kg. So we can say that 1 kg, the cost of 1 kg of mushroom is 1550 naira. So that is how to convert. So the cost of 1 kg of mushroom in the market is 1550 naira, and it is as simple as that. So this will be the end of our lesson. You can go through it after watching the video, then you have exercises to solve for you to just check if you understood all what has been taught in the lesson. So here we are told that in a cake shop they sell a single cake for 65 naira. So you have to complete this table. How much will they sell 2 cakes? That's been given to you already. So you have to find the amount they will sell 3 cupcakes, 4 cupcakes, 6 cupcakes, and 7 cupcakes, and use it to complete the table. You have to use the ratio of this to justify if the number of cupcake and the cost of cupcake are in direct proportion. So we are asked to tell them how many cupcakes have been sold at 780 naira. You know what you do before this? Before you can find the number of cupcakes that have been sold for 780 naira, you are first going to do what? You are first going to look for the relationship between the number of cupcakes and price and cost of cupcakes. So after that, you now Find the number of cupcakes that has been sold for 780 naira. So also we are told that 12 nights camp accommodation cost this. What will 7 nights cost? So 12 nights cost this. What will 7 nights cost? You know how to do that. So this also, they say 5 miles to every 8 kilometer. So we have to find how many miles, how many kilometers will 10 miles give, 20 miles, and so on. You mark out the ratio, you check if the miles and kilometers are in direct proportion, and also you look for the formula connecting kilometers and miles and find the number of kilometers in this number of miles, that is 45 miles, 115 miles. So that is the end of the exercise. Next video will still be on proportion, but then we are going to talk about the indirect proportion, we'll talk about the reciprocal. So, and that we are going to solve sample questions and solutions too. Thank you.